In this video, we are going to discuss about minimum spanning tree. So minimum spanning tree is something like we are going to derive from a graph. So in a graph, like take the given graph, like there are 6 nodes. And if I have a way of connecting all the nodes like this. So this is one way of connecting all the nodes without forming any cycle. Then this is called a spanning tree. A spanning tree is something like there should not be any cycle formed and a way of connecting all the nodes together. So that is called a spanning tree. So in the given graph, the graph that is given is an undirected weighted graph. So what is the meaning of undirected? So there is no direction given for all the edges, right? And a weighted graph, something where all the edges will have a weight for it. And a spanning tree is all the nodes has to be connected. There should not be any isolated node. And the connection should be in a way such that there should not be any cycles. Like see what we call it as tree. A tree is something like that doesn't have any cycle. We can compare tree with a graph. A tree, a graph with no cycle is called tree. A graph with no cycle, we can call it as a tree. And a spanning tree is something like where all the nodes has to be connected. There should not be any isolated node and no graphs or no cyclic structure. So that is called a spanning tree. So there are n number of ways a spanning tree is formed. So this is one way. And what is the cost of this spanning tree? Cost is each where edges has a weight, right? 3, 7, and 5. Okay, so this is the cost. Cost of this entire spanning tree can be written as 10 plus 4 plus 3 plus 7 plus 5. Okay, so it comes as 19. So this is the cost of this given spanning tree. And there are n ways in which a spanning tree can be formed. Like this is one way of finding a spanning tree. Like let us consider you have, there is no connection. 5 and 8, 3 and 4. Yeah, this is one connection. The blue line represents one spanning tree. See, all the nodes are connected once. And there is no cyclic pattern inside. And the cost of this tree can be written as 1, 4, 8, 5, and 6. So cost of this blue line is 1 plus 4 plus 8 plus 5 plus 6. Okay, and it goes on. So we'll be finding a lot of, there are n possible spanning tree available for each and every graph structure. And how can you find the minimum spanning tree? Minimum spanning tree is something like for the given spanning tree, the cost has to be lesser. So that is called minimum spanning tree. Okay, and consider the number of edges that are needed. The minimum number of edges needed to connect a graph structure is a graph with n nodes will have a spanning tree, a minimum spanning tree with n minus 1 number of nodes. Okay, so see this example. In this example, blue line represent one spanning tree and the graph that we have taken has 6 nodes inside. So how many number of edges are there? 1, 2, 3, 4, 5. So 5 edges, it is n minus 1 edges. Consider the red line. So that also 1, 2, 3, 4, 5. Okay, so to find a minimum spanning tree for the given graph structure, we have to consider the number of nodes and we have to find that n minus 1 number of edges with the minimal cost. Okay, so that is how we find the minimum spanning tree, and there are a few algorithms that works on the basis of this. Okay, so first algorithm that we see over here is like to find the spanning tree. One possible way is finding all possible spanning tree and find the minimum find the cost of each and every spanning tree and take the minimum one. But that is the worst ever case. The reason is like to find all possible spanning tree is really hard. Okay, and that too when the graph structure goes wider, it is really hard for us to take a spanning tree. to find all possible spanning tree. Okay, so we have two algorithms that are helpful in finding minimum spanning tree. The first algorithm is Prim's algorithm for finding minimum spanning tree. Okay, so Prim's algorithm actually focuses on, it starts from a source node. We are going to find a tree structure with minimal cost. So we'll be taking one source node. Okay, so let us consider one is my source node for the given example and find all the edges connected with one. So one is connected with four edges of the weight 10, 2, 1, and 4. So out of this, the minimal cost is for the edge one. So connect edge one. So edge one, edge with weight one connects node 1 and 5. See this graph? So this is the connection. Now node 5 was taken into account. So 5 is visited. Now find all the edges connected with 5. So 5 is connected with 4 edges, out of which one is already noted. So the remaining edges are with edges has the weight as 3, 8, and 7. Okay, so now include that into the list and find the minimum costed edges out of this. So we start from a node and find all possible connected node with minimal edge. That is the important thing over Prims. Okay, so Prims actually focus on a source node and finding a minimum spanning tree structure from that source node. Based on that source node, we are going to find the minimum spanning tree. Okay, so 1 is the source node and 1 is connected with 5 with the minimum, right? Now we are going to find all the edges connected with 1 or 5 with the minimum cost. Okay, so the next minimum cost edge is 2, and with this edge connects 1 and 3. So we'll be connecting it 1 and 3 with the cost 2. Now 3 is considered. Okay, so 1 is done, 5 is done, now 3 is done. 3 is connected with the edges of weight 6, 2, 8, and 5. So out of which 2 and 8 are already noted. So 6 and 5 will be added to the list. Now out of these things, we have to find the edge with minimum cost, and that is 3. So 3 connects 5 and 6. 3 will be added. Now 6 is visited. Now we have to find a minimum edge, like edges connecting 6. 6 is connected with 2 edges. One is of weight 3, which is already noted, and another is of edge 4, edge with weight 4, that will be added to list. And how many edges are needed for the given graph? The given graph consists of 6 nodes. And for a graph with 6 nodes, we need n minus 1 number of edges. So 6 minus 1 is 5 edges. Already we have find 3 edges. We need to find 2 more edges with shortest path for our constraint. Okay, with with lesser weight for our constraint. Okay, so out of these existing list, which one has the minimal weight? This H4 has the minimum cost. Now, when I include this H4 connects 1 and 6. But the problem is when I connect this forms a cycle. As I told you, a spanning tree doesn't have any cycle. So we cannot include this. So this cannot be included. This edge cannot be included for this. So we cannot include it. So we need 2 more edges with the minimum cost. So the next edge with the minimum cost is edge 5. Sorry, 5 over minimum cost. So that connects 3 and 4. So this can be included. And now 4 is included. So we have to include 7. All the edges are taken into constraint now. Okay. So now the next edge with the minimal cost is 6. Okay, 6 connects 3 and 2. Okay, so now all the nodes are connected and we have got 5 edges. So 5 edges are needed to connect a spanning tree. So all the edges are connected and everything goes with the minimal weight. So this is how a Prim's algorithm works. And the problem with Prim's is like this spanning tree may vary according to the source node that is chosen. So based on the source node that we chosen for the work, this spanning tree may work. And what is the cost of the spanning tree? 6 plus 2 plus 5 plus 1 plus 3. So that is the cost of this spanning tree. So this is our Prim's algorithm works. So it goes on a tree structure. Start from one node. It is going to find all the linked nodes with the minimal cost, and we are going to include it if it not form a cycle. Okay, so the next algorithm that you're going to see is called Kruskal's algorithm. That is also an algorithm for finding a shortest path. So the algorithm is called Kruskal's. And Kruskal's algorithm is going to deal with, you're going to find all the path with all the edges with the shortest path. Okay, so shortest path. So we are going to start with all the edges, and we are going to take only the shortest edge, and we are going to include it over here. So the edge with the lesser cost is 1, connects 1 and 5. So this will be included. We are not going to check whether it is connected or not. Okay, so that doesn't matter. We are going to choose all the shortest edge, and we are going to try to include it. If it form a cycle, ignore the edge. Okay, so the next one is edge that connects 1 and 3 with a weight of 2. It doesn't form any cycle, we can include it. Next, edge with cost 3 or weight 3 connects 5 and 6. And next is the lesser cost is edge with weight 4. Okay, so this connects 1 and 6, but when you are including it, it forms a cycle. A cycle should not be there in a minimum spanning tree, so we cannot include it. Okay, so this is done, this is done, this is done, and this is done. And out of the remaining, which has the minimal weight? It is this edge with weight 5 included. It doesn't form any cycle. And how many edges already taken? 1, 2, 3, 4. And how many edges are needed for forming a minimum spanning tree? We need n minus 1 number of edges. That is 6 minus 1, 5 edges are needed. So we need one more edge with minimal cost. So this is taken, and the remaining edges are 10, 6, 8, and 7. And the edge with minimal cost is 6 out of it. By connecting it, it doesn't form any cycle. See, now all the nodes are connected, and there is no cyclic pattern in it. And hence this is called a minimum spanning tree. So it is a minimum spanning tree. And what is the cost of this? 6 plus 2 plus 5 plus 1 plus 3. Okay, so with this, we can say that both Prim's and Kruskal's algorithm are useful for finding the minimum spanning tree. But the thing is, we have to, like, when how much ever time this Kruskal's algorithm is executed, it is going to produce the same result. The reason is, it is going to check all possible shortest path and try to include it. But when it goes with Prim's algorithm, when you are taking a logic graph, and it varies, each time when you execute with different source node, the spanning tree may vary. Okay, so that is the difference between Prim's and Kruskal's. Kruskal's are going to find all possible shortest edge included. Okay, whereas Prim's, it starts from a single source, and from that single source, it is going to form a minimum spanning tree. Okay, thank you.